Dear students, today we learn the equations of motion freely falling bodies. So already we know the equations: v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to as, and Sn equal to u plus a by 2 into 2n minus 1. These equations already will derived from different methods, right? So what do you mean by free fall bodies? So the free fall body is nothing but the momentum of an object only under the influence of gravity. So what do you mean by influence of gravity here? This is a earth surface. Suppose an object, you can take it, the height is h. So now you can drop this object, let it be the mass m. You can drop the object. So while it is dropped, we'll leave it, the object, without any velocity under gravity. It is moving downwards. That means initial velocity would be 0 while leaving that. While leave that, initial velocity will be 0. When it is strike the ground, before comes to rest, it has some final velocity will be there, that will be v here. So the displacement covered s equal to h. So due to under gravity it is moving downward, so acceleration is nothing but an acceleration due to gravity. So that g value, you know, that 9.8 meter per second square. In numerical sum 10 meter per second square also will take. So displacement s equal to h, time taken t equal to t. So now from first equation of motion, so what is the first equation of motion? V equal to u plus at. So v equal to u plus at, v equal to u0, will drop initial velocity 0, a is equal to g and t here. So v is equal to gt. So under free fall bodies, first equation of motion, this will be equation 1. So that means after 1 second, velocity v is equal to g into t, g 9.8 into 1, so that is 9.8 meter per second. After 2 seconds, velocity gt, that is 9.8 into 2, that is 19.6 meter per second. That means after 3 seconds, 4 seconds, that velocity will be increases till reach the ground. Velocity will be increases. So this is the first equation of motion. So from the second equation of motion now, second equation of motion. So what is the second equation? S equal to ut plus half at square. So s is nothing but a displacement, s equal to h, u0 will drop initial velocity 0 into t plus half gt square here. A acceleration a is equal to g, s equal to h here, u will be 0 here in this case. So h equal to half gt square. So that means a body dropped from the height. So let it be the body dropped 80 meters height, a g value take 10 meter per second. You want to calculate the time taken to reach the ground. How much time taken to reach the ground here? From this formula, you have to find root over 2h by g formula we can use. From this is one formula, and this is one formula for finding the height and time taken to reach the ground, a body dropped here. So what is the time taken here? T equal to root over 2h by g. So that means under root 2 into h 80 by 10. So under root 16, 4 seconds, like that. So suppose the body is time taken to reach the ground. Suppose while time taken is taken as a 6 seconds. So how much height it is dropped, from? So then you can use the for this h equal to half gt square formula. H equal to half g 10 into t square here, means 6 square here. So that means 5 into 36 here. So how much? The 5 into 36 should be 180 meter. So like that, have to find the time is given to find height is given to find the time. These are the two important formulas while free fall bodies. Next, the third equation of motion. So v square minus u square equal to 2as. So v square minus initial velocity 0 square 2g s nothing but a h. So this is the height h, s equal to h, u0, and it is velocity v. So then v square equal to 2gh, v equal to root over 2gh. So that means a body dropped, same thing, let it be take 80 meters. What is the velocity here? Root over 2g, h value take 80, even g value also you can take here 10 meter per second square. So 2 into 10 into 80, that should be how much here? 1600. So under root 1600 is 40 meter per second. So here while touch the ground, velocity before comes to rest, that is 40 meter per second. So this will be considered as a third equation of motion under falling the bodies. And the last equation of motion, Sn formula. So u plus a by 2 into 2n minus 1. So this is Sn nothing but to consider Hn. So Hn, that is u0 g by 2 into 2n minus 1 here. So therefore Hn formula g by 2 into 2n minus 1. So this is the last equation of motion in case of falling bodies. That means what we have to learn, what we learn in this for free fall bodies. Free fall bodies main condition: initial velocity 0, acceleration is equal to g, it has a time taken t, displacement s equal to h, it has a final velocity is there, final velocity will be there. But suppose see a body dropped 50 kg dropped, here one body dropped 40 kg. So if the both are in the same height, you can drop, the height is same, then the time taken will be for this body t1 and t2 should be same. That means irrespective of masses, the 550 kg and 40 kg, irrespective of mass, only depends on the height. So that means for free fall bodies, the equations of motion, first equation v is equal to gt, second equation of motion h equal to half gt square, third equation of motion v equal to root over 2gh, and fourth equation of motion hn equal to g by 2 into 2n minus 1. So these are the important equation to apply the applications according to the given questions. Okay, thank you.